How's it going, you guys? In this video, we're going to be talking about rational functions and kind of the different characteristics with it. So with rational functions, don't forget, it's like when we have f of x equals 1 over x, this is your parent function for it. It's what we explored in the last video. So we have a vertical asymptote. We also have a horizontal asymptote. These equations are going to change. We're going to start getting ones where it'll still be a rational function, but it may be something more like that. So we're going to have x's in the numerator, we're going to have x's in the denominator, and it will change how the graph looks. But in any situation, these are how to find the different characteristics of rational functions. So I'm going to zoom in just a little bit for you. Yep, boom! All right, so for an x-intercept, don't forget, we are somewhere on our x-axis, so the y is 0. For a y-intercept, we are somewhere on our y-axis, so the x is 0. Now for a vertical asymptote, this is the impossible x values is what I call it. So essentially this is, we cannot ever divide by 0. I can never have like 1 divided by 0 or 4 divided by 0. That is not possible. So when it is equal to 0, that is when we have our vertical asymptote. So the way to find our vertical asymptote is if we actually set the denominator equal to 0 and solve our function. You'll see how this works in just a minute. For a horizontal asymptote, there's a couple rules that we're going to be using. If it is called bottom heavy, and what I mean by bottom heavy, like it's just talking about the exponents. So like if I have something where it is f of x equals x to the second plus x over x to the third plus 2x squared plus x whatever. You look at the highest exponents. The highest exponent in the numerator is 2. The highest exponent in the denominator is 3. So the higher exponent is in our denominator, so I consider this to be a bottom-heavy rational function. So when it is bottom-heavy, y equals 0 is our horizontal asymptote. Every single time, no matter what. All right, if the exponents were equal, we take the coefficients of those things. So a situation for that would be if like we had 2x squared plus 7x plus 1, whatever, over 3x squared plus 3x minus 2, whatever. So again, looking at the highest exponents, we have highest exponents of 2 in both of them. So what I do is I take the coefficients as our horizontal asymptote. So our horizontal asymptote for this one would be y equals 2/3, and we could put that on the graph. All right, now let's actually graph some of these things using those rules. Zoom out just a minute. Come on, do it. All righty, we'll use this. So we have I usually go through and I find everything on this left-hand side here. I find my x-intercept, I find my y-intercept, my vertical asymptote, horizontal asymptote, throw all that on the graph, and then I see what my graph looks like. So for our x-intercept, don't forget, for a x-intercept, so for an x-intercept, that is when y equals 0. Y in our equation is the f of x, that is our output. So we have 0 equals 6 over x minus 3, and to solve that equation, I can multiply by x minus 3 on both sides. That makes 1. 0 times x minus 3 is 0, so I have 0 equals 6. Well, 0 doesn't equal 6, I'm pretty sure. So what this means is that we have no x-intercepts, so I could write none for the x-intercepts. Now for our y-intercept, that's when x is 0, so if I put in 0 for my x values, I have 6 over negative 3. 6 divided by negative 3 is negative 2. So I have a y-intercept at 0, negative 2. So I could put that on my graph. I know I'm going to be crossing the y-axis at 0, negative 2. Now for your vertical asymptote, again, take the denominator, set it equal to 0, and solve. So we have x minus 3 equals 0. Add the 3 to the other side. So my vertical asymptote is right at x equals 3. So when x is 3, I will have a vertical asymptote, a line that I cannot touch. I'm trying to find the right pen. So I have at x equals 3, I have a vertical asymptote. Beautiful. All right, now for the horizontal asymptote, I look at the highest exponent. There is not an x in my numerator, and there's x to the first in the denominator. So it looks like this thing is bottom heavy, which tells me I have a horizontal asymptote at y equals 0. So when y equals 0, so right on our line here, we have a horizontal asymptote. So then for actually graphing this thing, we've done everything we can, x-intercept, y-intercept, vertical asymptote, horizontal. I'm going to get closer to my asymptote in this direction, and I'm going to get closer to my asymptote in this direction. I knew it was on this side because I have a point here. I have to go through the y-axis right there. My graph has to. That's what we found that for. All right, now over here though, I don't know whether this thing is up here curving down like this, or I don't know if it's down here curving up. But what we can do is we have some x values. We have 4, we have 5, 6, 7, 8, 9, 10, whatever. So if I plug a number into my equation, so say I choose when x is 4 here. So if I do f of 4, then I have 6 over 4 minus 3, which would be 6 over 1, which is 6. So I have the point 4, so 1, 2, 3, 4, 1, 2, 3, 4, 5, 6. And that is getting closer to this asymptote then, and it must be getting closer to that asymptote in that direction. So that's how I know my graph is up top. All right, and then for the domain and range, for my domain is everything except for the x values we can't have. I know I can't have my asymptote here. So I go from negative infinity all the way up until 3, where my vertical asymptote is, and then I go from 3 to infinity. For the range, it's everything except our horizontal asymptote, so I have everything from negative infinity to 0 and from 0 to infinity. That's all the characteristics we are going to be looking for these graphs. All right, moving on, do another. I'll do a couple of these with you guys. So in this one, we have 2 over x plus 5. So for my x-intercept, again, set the equation equal to 0, so 2 over x plus 5. If I multiply by x plus 5 on both sides to solve for x, get rid of that fraction, I have 0 equals 2. 0 does not equal 2, so again, this has no x-intercepts, which is fine, no big deal. Now for my y-intercept, I can put in 0 for x, so I have f of 0 equals 2 over 0 plus 5, which would give me 2/5, which is fine. I promise that's a 5. That's a 5. It's not very pretty. So I put in 0 for x, and I got a y value of 2/5, which is about 0.4, so it's somewhere like right there. Right. For our vertical asymptote, set your denominator equal to 0 and solve, so x plus 5 equals 0 and solve, so I have a vertical asymptote at negative 5. And for my horizontal, I have a higher exponent in my denominator, so this is bottom heavy, so my horizontal is at y equals 0. If you want, you can go ahead and fill out your domain and range. You have negative infinity to negative 5, because it's everything except for the vertical asymptote, so I'm just not including that vertical asymptote. And then the range is everything except the horizontal, so negative infinity to 0 and 0 to infinity. All right, I'm going to go ahead and throw the asymptotes on my graph, so 1, 2, 3, 4, 5. Beautiful. And I have y equals 0 again. So just do your best with that y equals 0. I know it's kind of hard to see. And since I have a point above my horizontal asymptote here, I know it's going to be getting closer to the asymptote here and the asymptote in that direction as well. So I have that graph. Now I don't know what's happening on the left-hand side of my vertical asymptote though. I don't know whether my graph is up here. I don't know whether my graph is down here. But again, what you can do is you can plug in a point. So 1, 2, 3, 4, 5, 6. Say we choose negative 6 as our x value. So if I plug in f of negative 6, I would have 2 over negative 6 plus 5, which would be 2 over negative 1. So I would know I would be at negative 2. So that means negative 6, negative 2. So at this point, it must be getting closer to my asymptote there and closer to my asymptote over here. Cool. Again, that's all we're looking for this stuff. All right, same idea, different numbers. So still, x-intercept, always set your y equal to 0. So x-intercept, set your equation equal to 0, minus 1 over 4x plus 3. Always, same thing, multiply by your denominator. This time it is 4x plus 3. So that those divide, that makes 0. So I have 0 equals x minus 1. I can add the 1 to the other side, so x equals 1. Yeah! We actually have an x-intercept in this one. We have the x-intercept of 1, 0. All right. For our y-intercept, we need to plug in zeros for our x values. So f of 0 is 0 minus 1 over 4 times 0 plus 3. So that means my x or y-intercept is going to be 0, negative 1/3. Please make sure you guys are writing this as an ordered pair for me. It's not just some random number. It is the point 1, 0 and the point 0, negative 1/3. They're not just random numbers. So I can put on the point 1, 0, 0, negative 1/3. So it's really close to each other, but just do the best you can. And then for our vertical asymptote, set your denominator equal to 0 and solve. So I have minus 3 divide by 4, so x equals negative 3 over 4. X equals negative 3 over 4. So I have a vertical asymptote right, vertical asymptote right there. And then horizontal, notice here, I have x to the first up here. I have x to the first in my denominator as well. So I take the coefficients, and this would be y equals 1 over 4. So I have just barely above my 0, another asymptote. Right, so there's our asymptotes. For our domain, it's everything except the vertical asymptote, so negative infinity, negative 3/4, and negative 3/4 to infinity. And the range, everything except for the horizontal, so negative infinity to 1/4, and 1/4 to infinity. Cool. All right. We have 2 points on this side of the asymptote, so we know we're getting closer to the asymptote in both directions. Make sure you do not cross them, please. And then we don't know what's on this side. So say I choose, I don't know, like -1 or something. If I plug in -1 as my function. So f of -1 equals -1 minus 1 over 4 times -1 plus 3. This would give me -2 over -4 plus 3 is -1. So I have -1, 2 as a point, so -1 up 2. So it's getting closer to the asymptote in this direction and that direction. And there would be your graph. Beautiful. Let's do another. Hockey. All right. Doing good. Doing good. Tell you what, you're probably doing all right with this stuff. I mean, it's the same thing over and over and over and over. So how about for our x-intercept on this one? We have 0 as our y. So if you have 0 equals x over x minus 4, then I would multiply by x minus 4, our denominator. So we would have 0, 1, 0 equals x. That means we have an x-intercept at 0, 0. For our y-intercepts, plug in 0 for your x's. 0 over 0 minus 4. 0 divided by 4 is still 0, so we have the point 0, 0 for our y-intercept as well. For your vertical asymptote, take your denominator and set it equal to 0. So x minus 4 equals 0. So x equals 4 when you add it to the other side. For your horizontal asymptote, the exponents are the same, so we take the coefficients. So in this case, it's just 1 divided by 1 is 1. For your domain, the same thing. So everything except for the vertical asymptote, and range is everything except for your horizontal asymptote. And then graph those things. But those are how you find the characteristics. How about this? We'll just look down here. I'm going to look at number 8 in this one. And then we will move on to just a little bit more. So here, again, x-intercept. Set your equation equal to 0. I mean, I can't stress this enough. X-intercept, you find it the same way no matter what type of function you have. The y is equal to 0. So I can multiply by -2x plus 3 on both sides to solve for my x best I can. So then I end up with 0 equals 4x minus 1. Add the 1, divide by 4, and x equals 1/4. Please, again, write this as an ordered pair. It's not just some random number. It is the point 1/4 comma 0. So I'm somewhere right there. For our y-intercept, put in 0 for your x values because we are on our y-axis. So we have 4 times 0 minus 1 over -2 times 0 plus 3. So those make 0. I have -1/3, so I have 0 comma -1/3. So that is about right there. They almost look like they just make a blob together. Vertical asymptote. Again, as always, set your denominator equal to 0 and solve. That's really all it is. Subtract your 3, so you have -2x equals -3. Divide by -2, so x equals 3 over 2, which is about 1.5. So I have a vertical asymptote at 1.5. I feel like I messed something up. What did I miss? I don't know. Looks weird. All right. So then for horizontals, we have x equals 3 over 2. That's 1/4. And it is -1/3. Okay. 4th. Oh, I bet our asymptote's below this. That's what this is. Okay, so for our horizontal asymptote then, The powers are the same, so 4 divided by negative 2 is y equals negative 2. So I have a asymptote at negative 2. Now this makes sense to me. All right. So I must be, since I have a little blob here, getting closer to my asymptote in this direction, getting closer to my asymptotes in that direction. The only other place I don't know what's going on is on this left-hand side. So if I choose x to be like 2 or something, I can tell whether it's above negative 2 or below negative 2. So f of 2 equals 4 times 2 minus 1 over negative 2 times 2 plus 3. So that would be 8 minus 1 over negative 4 plus 3, which is 7 over negative 1, which is negative 7. So that means I'm way down there. So negative 2, negative 7, somewhere over here. So I must be getting closer to my asymptotes in this direction and that direction. That's pretty much all you guys are going to be doing for graphing these things. Domain, you can say negative infinity to the asymptote and the asymptote to infinity. And range, negative infinity to the asymptote and the asymptote to infinity. Because it just does not include the asymptote there. All right, moving on. We've got one more thing I want to look at with you guys. So we have just stating the horizontal and vertical asymptotes of each function. And zoom in just a little bit. Zoom in. Zoom in. Do it. Do it. Thank you. You're welcome. I have my little helper dog with me. All right, so for horizontal and vertical asymptotes, for the horizontal, super easy. Make sure you know your rules. If this thing is bottom heavy, it looks like it is because we have x to the first up here, x squared in our denominator, so this thing is bottom heavy, so we have y equals 0 as our horizontal asymptote. For the vertical asymptote, take your denominator, your entire denominator, set it equal to 0 and solve. So this one I would have to factor such that I get negative 2 and negative 1 as asymptotes. So don't freak out when you see that. You just have two asymptotes, and that's totally fine. That would mean we have asymptote at like negative 2 and negative 1. We had our horizontal at y equals 0, so we may have a graph that looks something-ish like that. You won't have to graph these things. You're just telling me what the vertical asymptotes are. But this is what it means if you're curious. This is kind of ish, not exactly. I'm just guesstimating. But it could look something like that. We could also have this middle part go through our horizontal asymptote. But whatever. You won't have to graph these until you get to pre-cal though. All right, moving on. Same idea. For the horizontal asymptote, is it top heavy? Is it bottom heavy? Is it equal? In this case, it's equal. We have squared and we have squared, so we have 2 over 1, so y equals 2. For your vertical asymptote, set your denominator equal to 0 and solve. And factor. And take out your solutions to find your two vertical asymptotes. All right, one more. So close to being done. Yes. All right, horizontal asymptote looks like this thing is bottom heavy, so y equals 0 is my horizontal. For the vertical, take your denominator and set it equal to 0. And solve. So in this case, again, we have to factor. And there are our two vertical asymptotes. There's our horizontal. All right, hopefully this video has been helpful for you guys. Sorry that I didn't make any like weird noises too much, but